Hello, everyone, and welcome to the first module of the DevOps Mentorship Program. For starters, who am I? I am a build and release engineer working at Jagex. Previously, I worked at Bosch in the smart home and thermotechnology teams as a DevOps engineer for more than 1 year. Before that, I was a cloud engineer at Altis, one of the biggest European ICT companies in the market. I was also an assistant lecturer on the network and systems management at the Faculty of Engineering of the University of Porto for a total of 2 semesters, if I am not wrong. So, what is DevOps? Usually, when I ask someone what DevOps is, the answers I get are less than confident and they are often conflicting, as shown in the elephant slide below. Some people consider that DevOps is a mix of cultural practices and automation. Others just side with the purely technical aspect of it. Well, in essence, they are all partially correct. It is not easy to clearly point out what that DevOps is, especially when organizations look at it in the forms that best suit their needs. In an effort to try to finally solve this issue, this problem, an industry standard was developed by the Institute of Electrical and Electronics Engineers. And to provide a brief background about its purpose and relevance, this standard mainly specifies technical principles, practices to build, package, and deploy systems and applications in a reliable and secure way. The standard also describes how to establish effective compliance. Most of the DevOps principles like mission first, customer focus, left shift, continuous everything, and systems thinking. I will make a copy of this document available to you after this presentation. So what is it? What is DevOps? So DevOps is pretty much a set of practices and cultural values that enterprises are increasingly adopting as a way to improve the software development feedback cycle and try to increase customer satisfaction. There are many practices, but the most popular are infrastructure as code, automated testing, continuous test integration, continuous delivery. They are often coupled together in the typical CI/CD infrastructure that most of the developers are used to work with, and release management. So to understand the core principles of DevOps, like I said before, we should start with the mission first. The mission first principle in DevOps emphasizes aligning the software development and delivery processes with the organization overall mission and goals. This involves understanding the broader objectives and priorities of the business and to ensure that the development and operation efforts are focused on delivering value that supports those goals. The customer focus principle. Well, that is a strong emphasis on customer satisfaction and meeting customer needs. It is transversal to a lot of principles in other strategies of development. It is not unique to DevOps, but in DevOps, teams need to strive to understand customer requirements early, not only operational, but also non-operational requirements. Um, they gather feedback and incorporate it in the development process. So this customer focus involves actively engaging with customers, delivering features and updates regularly that address most of their pain points and to ensure a positive user experience. Left shift, we heard about left shift a lot. So what is left shift? Left shifting in DevOps refers to moving tasks, activities, responsibilities, etc. earlier in the software development cycle. It involves integrating activities such as testing, security, and performance monitoring as early as possible in the development process, not only when it is released. By shifting these activities leftward in the development cycle, issues can be identified and resolved much earlier, leading to overall better quality software and faster feedback loops. And finally, continuous everything. So the principle of continuous everything in DevOps is about promoting automation, integration, continuous improvement across the software development lifecycle. It encompasses practices such as continuous integration, continuous delivery, continuous deployment, continuous testing, continuous monitoring. So, like the name says, continuous everything. These aim to enable a seamless and iterative flow of development, testing, deployment, resulting in much faster and much more reliable software delivery. And what are those benefits? DevOps has revolutionized the software development processes, which brings significant impact. The most obvious one is faster time to market, so increasing speed and frequency of software releases. Improved collaboration and knowledge sharing amongst teams, and also cross-functional teams. Okay, so that there is no more silos between teams, between development teams and operational teams. No, they are cross-functional. It also helps to enhance software quality and customer satisfaction, create a continuous feedback strategy and faster problem resolution, culture of continuous learning, innovation, improvement, and these impacts have transformed the way that organizations develop, deliver, and maintain software. And the main question here is, how is this implemented? So implementing DevOps involves a combination of technical practices, cultural changes, and process improvements. While the specific implementation may vary depending on the organization's context and goals, there are some common steps and considerations involved in implementing DevOps. The first one would be, in my opinion, assessment, so that we as an organization need to evaluate the current processes and identify pain points, set clear objectives aligned with business goals, and try to mitigate those pain points. Cross-functional teams, like I said before, we need to stop having silos between development teams, operational teams, marketing teams. We need to form teams with diverse skills and shared responsibilities. Automation. Identify as much areas as possible for automation to streamline processes. I will talk more about this in the next slides. Continuous learning, like I said before, and I will continue to repeat it over and over. Embrace a culture of learning and improvement. That's the only way a culture can thrive nowadays. And to this, we must have leadership support. So the leadership should secure resources and buy in to that continuous learning feedback. But overall, just remember, DevOps is an iterative process. Start small, adjust as you go. Don't try to rush it, don't try to implement it all at once. Be aware, DevOps, site reliability engineering, and platform engineering are especially in LinkedIn and most forums are treated the same way, but they are not the same. They are related disciplines that share common goals and principles, but they focus on different aspects of the software development and operational ecosystem. DevOps mostly is a set of practices that combines development and operations to improve collaboration, streamline software delivery, enhance the overall efficiency and the quality of software development lifecycle. It mostly emphasizes in cultural and organizational changes, automation, continuous integration, delivery, and collaboration across teams. Now, software site reliability engineering is a discipline that applies software engineering practices to operations and focuses on building and maintaining reliable and scalable systems. Software reliability engineering teams are responsible for mostly ensuring the reliability, performance, and availability of applications and services in production environments. It aims to bridge the gap between development and operations by applying software engineering principles, automation, and proactive monitoring. Now, platform engineering mostly focuses on building and maintaining the underlying platform or infrastructure, as you will, on which applications and services are developed and deployed. Platform engineers mostly design, build, and optimize the platforms that support the software development and delivery processes. This can include creating and managing container orchestration systems, cloud infrastructure, CI/CD pipelines, and other related tools. This aligns with DevOps principles by providing most of the necessary infrastructure and tooling support the development to the development and to operation teams. It aims inside organizations to create a self-service platforms that enable developers to rapidly and efficiently build, deploy, and manage applications while maintaining stability and scalability as much as possible. So, what is the role of automation in DevOps? So, in my opinion, automation plays one of the most pivotal roles in successful DevOps implementations, revolutionizing the software development lifecycle as much as it can. Some of its key aspects are efficiency, because automation mostly eliminates manual, repetitive tasks, which enables teams to focus on more valuable work. By automating processes like build, testing, deployment, organizations can achieve much faster and much more frequent software releases. This leads to accelerated time to market, improved productivity, and increased customer satisfaction. Consistency and reliability. So, like I said, manual processes are prone to human error and inconsistencies. These automations ensure that there is consistency and, most of all, predictable outcomes, which reduce the risk of manual error in errors of code deployment and even infrastructure configuration. With reliable automation in place, teams can deliver software seemingly and with some sense of reliability. Then comes CI/CD, which is basically what every developer is used to work with, automation tools that implement the robustness of CI/CD pipelines, automate the merging, testing, and much more of code changes, which allows teams to catch issues early. So like the fail early strategy. And this mostly ensures code quality. Continuous delivery kind of automates the release processes. Of course, that there might be business and other operational reasons not to automatically deploy, but it can be deployed. The code is always on a ready to deploy state. So, which makes the release process efficient and most of all repeatable. Testing and quality assurance processes in DevOps, they are basically the same across non-DevOps um, teams and organizations, which ensure high quality software releases, reduces defects, and tries as much as possible to improve overall product reliability. Reliability is one of the most sense of focus that we will see in DevOps. Finally, monitoring and alerting extends a little bit that predictivity and proactivity identification of issues and prompt responses accordingly. Automated monitoring collects real-time data, triggers alerts based on predefined thresholds, and can even perform, to some extent, automatic remediation actions like self-healing tools. This allows teams to quickly detect, diagnose, and resolve issues, and tries as much as possible to minimize downtime and to ensure a positive user experience. Some of the tools that enables us to perform these automations are in terms of configuration management tools, Ansible, Puppet, and Chef. These tools try to automate the provisioning and management of infrastructure and application configurations. They facilitate consistency and, most of all, scalability by predefining infrastructure and application configurations as code, which in turn reduces manual effort and ensures reproducibility. ISC tools such as Terraform, AWS CloudFormation, and much others like Azure Resource Manager and many others. They try to automate the provisioning and management of cloud infrastructure resources. With ISC, infrastructure configurations are also defined as code, which in turn enables teams to version, test, and deploy infrastructure changes reliably and efficiently. Like I said before, CI/CD enables an automated approach to the process development stream and its deployment process. It can involve numerous steps like continuous integration of code changes, automated testing, build, seemingly trying to deploy to various environments, etc. It can be whatever the development teams deem necessary. And finally, a wide range of testing tools exist to try and automate different aspects of the software testing. Of course, that these mostly depend on the industry that you work in. For example, in the gaming industry, it is much harder to maintain automated testing, but in more conventional industries like home improvement industries, home automation industries, and other automations, these tools are mostly Selenium, JUnit, Cypress, performance testing tools like JMeter, Gatling, and we could even try to leverage some of the security testing tools like OWASP and Burp Suite. They try to test processes, validate application functionality, and try to help and identify and prevent defects or even vulnerabilities. Continuous integration is a critical practice in DevOps that revolutionizes the software development process. This enhances collaboration, code quality, and delivery speed. CI involves or can involve continuously integrating code changes from multiple developers across an organization and across the shared code repository that can spread across multiple organizations. So many companies can be working on the same project, and CI ensures that all changes are frequently merged, reducing the risk of integration conflicts, and again, enabling early detection of issues, which in turn improves reliability. Automated builds and tests can be triggered upon code integration, and this compiles the code and generates executable artifacts or images, whatever type of artifacts that your application is creating. And this can also incorporate automated testing, including any type of test really, like unit test, integration, smoke tests, whatever you want. And this is a persistent and continuous effort to validate code changes. It also enables us to have a fast feedback loop, which can immediately warn of a developer that it changes, created some conflicts, created a bug, created a new vulnerability, so that the developer is alerted as quickly as possible and as early as possible. In terms of more of an internal side, the CI fosters collaboration among development teams and provides visibility to the developers. Now, continuous delivery is basically an extension of CI. You cannot have continuous delivery without even having continuous integration in the first hand. And it builds upon CI to a step that takes software delivery to the next level. It focuses mostly on automating the entire process from code integration to deployment, and ensures rapid and reliable releases. With continuous delivery, we get seemingly transitions to an automated deployment pipeline. This pipeline is mostly consists of stages as building, testing, deploying, whatever you want it to have. It is mostly incremental and frequent. So the CD pipelines need to act upon each change. It is wrong to have it only happening during the deployment to production or even to Q&A. It needs to happen with each integration. It also allows us to have a possibility of version controlling, and again, it helps on the feedback loop to enable the developers to know as early as possible that they need to act upon an action point. This is only possible due to monitoring and feedback loops, which again are integral components of DevOps practices. They provide valuable insights, many driving continuous improvement aspects through the software development and delivery lifecycle are only created due to having monitoring in the first place. Most of the times, what DevOps tries to achieve is a real-time monitoring of the implementation of the application in order to collect data that is as actual as possible, not only on the actual application performance, but also on its health and even user behavior. Such monitoring tools can be Prometheus, Grafana, and New Relic. They mostly enable organizations to track these metrics, identify bottlenecks, and proactively try to help organizations to address issues. Now, another very important point that is not mentioned here is incident detection and response, because monitoring facilitates early incident detection by setting up alerts and triggers that are based on predefined thresholds. When an issue arises, the monitoring system should be sufficiently autonomous to alert the appropriate teams, which in turn enables swift response and minimizes downtime. These monitoring tools also provide data for feedback loops to help enable organizations to gather insight from users, stakeholders, and even internal teams. And this valuable information about user experience, application functionality, and areas for improvement, such as user surveys, user testing, feedback channels, whatever, align the organization, they help the organization to align their development efforts to meet user expectations. Root cause analysis and continuous improvement is also facilitated due to monitoring tools, and by analyzing data, which can come in any form like logs, feedback, teams can identify underlying causes and implement corrective actions. Collaboration is not one, so organizations take collaboration for granted, but in most of the cases, and in my experience, it's not as granted as organizations believe it to be. Collaboration is at the heart of DevOps. It helps to bring together cross-functional teams to work towards a common goal of delivering high-quality software efficiently and effectively. These cross-functional teams should be formed not only by developers, but also from different disciplines, basically operations, quality assurance, security, even product management. These teams collaborate closely, they are highly cooperated, and they should iterate through the software development lifecycle together and foster shared ownership and collective responsibility. For that, They must have regular and effective communication. That is crucial to enable collaboration in DevOps. Teams should establish open channels of communication, such as regular meetings, chat platforms, collaboration tools, whatever it takes to ensure transparency and to facilitate seamless information sharing. Cultural transformation is a key aspect to achieve that level of collaboration. So DevOps promotes a culture of collaboration, breaking down silos between teams and try to get to a point where people have a sense of shared responsibility. Building trust among team members and encouraging open communication without penalties are crucial for this collaboration to be effective. Individuals must be encouraged to experiment, learn from failures, not be disciplined by it, and to continuously improve their skills and processes. Embracing this type of cultural change can be difficult, but it's ultimately crucial to foster adaptability and innovation within the organization. It is noteworthy that implementing DevOps brings numerous benefits, but it also comes with unique challenges and considerations. Some of the most common challenges organizations may face and some important considerations to take out of it when adopting DevOps practices are moving from traditional siloed hierarchical structures to a collaborative, horizontal, cross-functional approach. Organizations need to foster a culture of collaboration. I cannot express this enough. Continuous learning must be in place. Innovation support success to innovate and to support success of DevOps adoption. One cannot say that they have a DevOps culture where teams are afraid to collaborate and to express failures. Also, trying to maintain security and compliance while adopting DevOps is hard, but at the same time crucial. Organizations must implement robust security measures, including not only securing code practices, but also continuous security testing and strict access controls. These will be approached in the future in other models, but just bear in mind that this must be done. Another issue is automation complexity. Um, Automation, like I said before, plays a vital role in DevOps. But oh boy, it can introduce its set of challenges. Organizations must plan carefully plan and realistically, and implement automation to try to avoid over complexity. It needs to start small with simple, manageable automation tasks and gradually expand, scale up to more complex processes. Don't start at the most complex tasks. Start small and iterate above it. Another persistent problem that I found in my experience is that organizations do not invest sufficiently in training and upskilling their teams to assure that they have the necessary expertise to efficiently implement and manage these practices. Skill gaps should be closed, and new technologies and practices must be learned through trainings in order to leverage their potential to the maximum. And finally, legacy systems. Integrating DevOps with legacy systems and applications can be challenging. Um, Most of the times, legacy systems have limitations in terms of technology stack, deployment process, scalability, even stability. Organizations need to carefully evaluate and plan for the modernization or, at the very least, integration of these systems to ensure smooth DevOps adoption. For this, the combination of DevOps and cloud computing may help to create a more smooth transition because DevOps and cloud computing have a powerful synergy between them that accelerates software development, enhances scalability, and it enables also faster time to market, really. There are several ways that this energy can come to your attention, but most of them are like with infrastructure automation and configuration management, where DevOps practices even rely on it. Um, Cloud computing platforms offer extensive APIs to help to have the infrastructure as code tools and configuration management systems in place, which in turn allow teams to automate infrastructure provisioning, configuration, and management. Of course, that by having this versionized and automatized, eliminates manual errors, ensures consistency, and improves infrastructure agility to scale up and down. And with this elasticity comes an unparalleled scalability that allows applications to handle varying workloads. So they can quickly auto scale up and down and create dynamic resource allocation to ensure optimal performance, high availability, and most of all, cost efficiency. Scaling up and down on demand, it becomes seamless, very easy to achieve when using cloud resources for that goal. Some cloud computing platforms also provide a centralized and collaborative environment for the DevOps teams with shared access to the cloud-based resources, tools, repositories, which in turn enable teams to collaborate effectively, share code, and work on common goals. There are some case studies of DevOps implementations that I would like to share with you. Netflix, which everyone knows as a leading streaming service, embraced DevOps to improve its software delivery process by implementing a culture of automation, continuous integration, and continuous deployment. Netflix achieved rapid feature releases, increased system resilience, and even improved the customer experience. Their DevOps practices enabled them to scale their platform globally while maintaining high availability and very, very fast deployment cycles. Amazon, which was one of the pioneers of cloud computing, tried to adopt successfully DevOps to enable frequent and reliable software releases. Most of the times, one doesn't even recognize that there is a new software, a new version released in Amazon services. Their DevOps approach streamlined the development, testing, and even the deployment processes, which extremely reduced time to market and improved operational efficiency. By leveraging automation and infrastructure as code, Amazon really achieved significant scalability and flexibility in managing their very, very vast infrastructure. Now, Google, as most probably know, is closely tied to DevOps, but they created their own thing, which is site reliability engineering approach. Site reliability engineering basically combines software engineering and operations to build robust, scalable, and reliable system. And by applying DevOps principles to it, Google ensured that its services are highly available, performant, and resilient. Their success is basically a combination of its commitment to automation, continuous integration and deployment, infrastructure as code, cross-team collaboration, and innovation. By embracing these principles, Google can be able to deliver highly reliable services while also at the same time driving continuous improvement and pushing the boundaries of innovation. And a lesser known example is Etsy, an e-commerce marketplace that implemented DevOps to enhance their software delivery and improve the customer experience. By embracing continuous integration and continuous deployment, they reduced deployment time significantly. We are talking here about at first their deployment times were about 3 to 4 weeks. And we are back. It seems like Zoom is time gated for the free version of it, which I did not consider when creating the PowerPoint, so I'll bear this in mind for future sessions. So I was talking about Etsy. So Etsy is an e-commerce marketplace that implemented DevOps to enhance their software delivery and improve the customer experience. By embracing continuous integration, continuous deployment, infrastructure automation, Etsy reduced deployment times from weeks to hours. Like I was saying, it used to take about 3 to 4 weeks for each deployment, and nowadays, with the introduction of DevOps practices, they managed to shorten that time to market, so that deployment time, to about 2 or 3 hours, depending on the services or the scale of the services that they are updating. So as you can see, coming from 3 weeks, 3 to 4 weeks to 2 to 3 hours is a huge increase in time to market. Their DevOps practices also fostered collaboration between development and operation teams, so that operation teams need to also be comfortable in this speed where software reaches the end user, so that they can properly um, uh, be sure that quality and reliability is in place. So it does not suffice to quickly deploy. You must be sure that your deployments are reliable, secure, that they will not crash if a user goes bananas and clicks something that they shouldn't. So this appeasement of operational teams must be done if DevOps is to thrive in a company. Well, I hope that these 4 case studies were enough to demonstrate the transformative power of DevOps in diverse industries and contexts. And now, finally, let's see what future trends and emerging technologies might affect DevOps. Like every other field, DevOps is rapidly evolving. It is driven by advancements in technology, ever-changing business requirements. And in those trends, we can find, like I said previously, something that was created or at least coined by Google, which is site reliability engineering. That emphasizes mostly on the reliability, automation, and incident management. It tries to bridge the gap between development and operation teams by promoting a shared responsibility and a focus on system stability. They basically incorporate practices such as proactive monitoring, incident response, and even error management to minimize service disruptions and enhance resilience. This, of course, leverages automation and infrastructure as code to efficiently manage their infrastructure, freeing up time for actually working on those action points that are raised during the monitoring of the system stability. And by also integrating security and compliance considerations inside reliability engineering, we can ensure that reliability is not compromised and that it fosters a strong security posture. Um, by embracing site reliability engineering as an extension of DevOps, organizations can, or better yet, enable themselves to deliver reliable services, maintain scalability in very complex architectures, and at the same time meeting the evolving demands of not only the users, but also the modern software development and operation practices, best practices. It is also noteworthy, it's not a practice, but it's more of a technology slash tool, Kubernetes and containerization. Kubernetes has emerged as a leading container orchestration platform. Most of you know it. And Kubernetes enables efficient deployment and management and even self-heal of containerized applications. As DevOps practices continue to embrace microservices architecture, Kubernetes provides scalability, portability, and even automated scaling capabilities. It is pretty much widespread even at this point, and its adoption is set to continue as organizations still strive for cloud-native development and containerization. The integration of artificial intelligence and machine learning within DevOps practices and technologies is also on the rise. It is also sometimes known as AI ops. These AI/ML algorithms can analyze large data sets, identify failure patterns, provide valuable insights for optimizing software processes, etc. From this etc. can extend much more. This from automating code reviews to predicting system failures, really. AI and machine learning have the potential to enhance efficiency, quality, and reliability in DevOps workflows, and there have been some significant progresses in this field. AI ops platforms can even analyze vast amounts of monitoring data to try and detect anomaly patterns and provide predictive insights, which in turn enables proactive monitoring, not only passively monitoring, but also proactive monitoring, so that we can try to predict incidents before they even happen. By leveraging AI ops, organizations can just enhance system reliability exponentially. They can optimize resource utilization, and really, this is a field that may be on the final step to drive operational efficiency to a point that it was never even considered to this day. Yes, AI and machine learning ops can help faster production as well. Yes, so not only on the operational field, but also even on the development side, there are numerous tools nowadays that can help you achieve it. And I do know for a fact that in 2024, there will be even a new CI/CD tool that will be released that has built-in AI and machine learning algorithms to try and to help the developers um, to predict better ways to improve um, the performance of the features that they develop. And yes, I will share the presentation after this. Now, the point number 4, we have GitOps. GitOps is basically an emerging practice that leverages Git as the single source of truth for not only the code itself, the application itself, but also the infrastructure and deployment automation. It enables declarative and version-controlled management of infrastructure and application configurations, which in turn reduce manual intervention and ensure consistency. GitOps basically streamlines the deployment process, enhances auditability, which is something that I will also cover in future models, and helps to promote collaboration between development and operation teams. Finally, we have DevSecOps. With security becoming an integral part of DevOps, DevSecOps is gaining performance and preeminence, not performance, sorry, is gaining prominence. These practices emphasize integrating security into the DevOps lifecycle from design to deployment so that DevSecOps promotes automated security testing, vulnerability scanning, secure code practices, and this ensures that security is not an afterthought, but an inherent part of the development process. So it is not only considered when the application is on production, it needs to be considered even when the application or service or whatever is still in the process of design. Staying abreast of these trends can help organizations and even individuals to stay competitive in the market and leverage the full potential of DevOps. So what should we get from this presentation? What should we learn from this? So in summary, DevOps is a transformative approach to software development and delivery, and it is characterized by its principles and mostly its associated benefits. DevOps enables organizations to achieve faster time to market, improve quality, and enhance collaboration between teams and even inside the teams themselves. It fosters a cultural transformation that values collaboration and teamwork, and basically it lays the foundation for almost every industry to thrive for success. One key takeaway is the importance of embracing DevOps principles and understanding the core of the benefits that they bring. By implementing DevOps practices, organizations can achieve speed, collaboration, quality, etc. But they need to understand that it's not only migrate to cloud and expect wonders. They need to understand the best practices that they need to follow to thrive in the market of DevOps. Automation, continuous integration, continuous deployment, continuous delivery, it all plays a critical role in enabling efficient DevOps and streamlining the software delivery pipeline. Another crucial aspect should be the emphasis on monitoring and feedback loops, which are basically the key to drive continuous improvement. By continuously monitoring systems, collecting feedback, and especially making data-driven decisions, organizations can identify areas that need improvement and in turn optimize their processes. So overall, the successful adoption of DevOps requires a holistic approach that encompasses cultural transformation, automation, continuous integration and delivery, and effective monitoring and feedback loops. By embracing those principles and practices, organizations are able to unlock the full potential of DevOps and reap the benefits of it faster and more reliable software delivery. And with that said, here comes the best part for all of you, the end. Thank you for attending this first module. I will, like I said before, I will make the presentation and EEE standard document available for you. And I will upload the record of these two meetings on YouTube and send the link on the Discord. Since we are time gated on Zoom, I will try to change this a little bit for the future in order to have a break in between so that we don't suddenly cut off. And yeah, thank you very much once again, and I hope you have a nice day.